Science of language in the language of science. Every discipline that has embraced the empirical paradigm has progressed immensely ever since. Linguistics has just begun on that path. While the vast majority of linguists still looks at that effort with disbelief, the few linguists involved in this project are still searching for the best way of applying scientific method to the study of language. In this video, I shall present one of such possible paths, inspired by the philosophical research of Mario Bunge, possibly the best philosopher of empirical sciences in modern times. The proposal presented in this video is in most general aspects similar to that by George Kingsley Zik, put forward about 70 years ago, which at that time went unnoticed by linguists. A somewhat different approach to scientific study of language that could be taken, and is certainly worth considering but will not be discussed here, was proposed in late 70s of the 20th century by Gabriel Altman. Before proposing how to study language with the methods of empirical sciences, let me remind you what differs research in humanities from that in natural sciences. Well, in the former case, first, researchers tend to focus on specific items and aim at their full descriptions. Second, they use qualitative methods, natural language, and interpret their observations. In sciences, on the other hand, scientists focus primarily on categories, classes of objects or processes. Consequently, they are interested in selected characteristics of a given class or process. They do not aim at arriving at as full a description of a given item as possible. However, one can, of course, model also a specific instance of a category. For instance, one may model the Earth, not only a planet. Second, scientists favor quantitative investigations, which are the result of some objective measuring procedures. Yet, we mustn't forget that people made wonderful discoveries about the world resorting to natural language. For instance, ancient Greeks figured out that the Earth is round by observing the shape of its shadow on the moon. Therefore, in new disciplines, theories can be rightly expressed in a natural language at first. And third, scientists use scientific method, which consists of two types of activities: searching for quantitative patterns and looking for explanations. To illustrate that former type of activity, we may look at Kepler. Kepler noticed, having considered Tycho Brahe's data about the movement of the planets around the Sun, that planets move around the Sun along ellipses. He found a pattern. The second type of scientific activity is looking for explanations. This takes place in three steps. First, proposing models reflecting the mechanism of a phenomenon under study with the help of theories. Second, testing these models. And third, if necessary, correcting models or even substituting them with new ones, or correcting the theories involved in constructing these models. In other words, historically speaking, exclamation follows finding some pattern, regularity, yet in advanced disciplines, one often starts with proposing a model right away. To sum up, the difference between arts and sciences is not in what you study, but in the methodology, how you study. For instance, texts can be studied both by literary critics and disciplined linguists. What needs to be clarified before moving on are the concepts of a theory and a model. These terms are used interchangeably in everyday speech and roughly refer to some description of a given phenomenon or object. However, these terms have also specific technical definitions, one in mathematics and another one in empirical sciences. Below I shall define models and theories in empirical sciences as explicated by Mario Bunge in his book Method, Model and Matter. So on this view, models are simplified representations of reality. These are never copies of reality. Think what would happen if maps had all the details of a city. Then they would need to be the size of a city and one would not be able to use them to see where to go. Importantly, there is no one model of a given phenomenon, but every model depends on the purpose of investigation. For instance, when studying the movement of a bird, and ornithologists will consider different aspects of birds, such as a season, the migration pattern of these birds, the sex of the bird he's observing, then a hunter, intending to find the bird he has just shot. The hunter will approximate the bird as a material point and use Newton's laws to estimate where it would fall down. In other words, models include approximating conditions dependent on the purpose of investigation, which are absent from theories. Theories, on the other hand, describe general aspects of phenomena and are not testable per se. For instance, Newton's theory of gravity or Newton's dynamic. What is testable are models which in advanced sciences are created with the help of such theories. Both models and theories represent mechanisms which account for the origin or sustentation of some object or process in a given environment. For instance, one may build a model to account for the way the Earth moves around the Sun. In this case, intending to use Newton's theory of movement of material points, first we model both the Sun and the Earth as material points, thus objects with a zero volume, located at certain distance away from each other. Next, we assume that these material points behave according to the theory expressed by Newton.